Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at the homework for lesson 3.1.2. This should go a little bit quicker than the previous homework. Pretty straightforward math here. All right, so take a look at a table. Generally, you want to look at the information that they've provided, and you're looking for a pattern here. So what do you do to the 2 to give you 5 for an answer? You could think of adding 3, but it doesn't work for the other 2. So you can think, all right, there must be some multiplication process or division, but more than likely it's going to be a multiplication process here. So let's say I double the number 2. What do I have to do then to get the 5? I have to add 1. So if I double the 10 and I add 1, that's the combination that we need. So to verify it, double the 6 to get 12, you add 1 is 13. So that is our rule that we're going to apply. So every time we know the input number, we will double it and add 1. And if we know the output number, we have to take away 1 and then take half of it. So you kind of go through the reverse order of solving it. For instance, if you take for -15, you feel confident that this is your rule, then we will plug in the -15 for our output, and we are going to leave x for our input because that's what we're trying to figure out. So you have to subtract the 1 instead of add it. And remember, we're dealing with integers here, so -15 minus 1 is the same as -15 plus a -1. So that gives you -16. And what do you multiply times 2 to give you -16? Well, that would be -8. And so that ends up being your input number. Okay, so the more times we do this, looking at the numbers, guessing and checking at a pattern, and I know a lot of you have practiced with this because those little bonus puzzles that I've added onto our assessments and chapter tests often have us doing something along these lines. So you've had a lot of practice over the past year, especially if you were with me in 7th grade, doing this kind of a process. All right, so let's never lose sight of these steps that we use, the legal moves, and I promise you we are eventually going to leave these algebra tiles behind and just work with equations. But still, it's good. You always want to start off by writing out the original equation. So 2x plus 3 minus an x minus a -1. And if you wanted to picture that being moved across the street, this becomes plus a +1. And this x would then become a -x, which would cancel out with the positive x to make a 0 pair. And then you'd end up with 1x plus 1, 2, 3. And then this guy was its opposite, 4. On the left-hand side. On the right side, move this guy across the street. It becomes part of those 2 x's, so it becomes 3 x's, and then plus a -2 or -2 if you want to just write it that way. And then from this point, you can take away an x from each side, and you can add 2 to each side. Oops, I guess I did that in the next step, didn't I? Then you add 2 to each side, and that's how eventually you get your x is equal to 6, so x has to be equal to 3. On this side, if you've done all the legal moves, you would have actually gotten a fractional answer, which is sort of impossible to model using the algebra tiles. It's okay because we're going to leave those behind anyway as we start getting deeper into rational number answers. Evaluate the following expressions given the values. Okay, so this is pretty straightforward. If you know a is equal to 2, any place you put an a, no, that's not an a. Any place you put an a, replace it with the 2. Any place you see a b, replace it with a 5. So you're going to put a 5 there, you're going to put a 5 there. Sorry, I had a little interruption. And then for the c, any place you see a c in here, replace it with the number 3. So whenever you've got variables next to each other, that always means that they're being multiplied together. So this is going to be 2 times 5 plus 5 times 3 plus 2 times 3. No, yes, 2 times 3. That's 2, that's 3. So now, order of operations, take care of all the multiplication first. Then you can add, and you end up with 25, 31 as your final answer. For part B, you've got x is equal to -2. So this is where it becomes kind of tricky, because that -2 there, a lot of times students want to think the minus sign in the expression is the minus sign or the negative sign for the 2, but it's not. It literally says 20 minus whatever x is, and x happens to be -2, squared. And then you're going to divide all of that by whatever y is minus whatever x is, and once again, x is -2. So that minus sign cannot be a replacement for the negative sign in the -2. You've got to put everything in there. So that's why I always recommend, whenever you do this work and you substitute a variable in, I always like to put parentheses around it, especially if it's a negative. Okay, so this is 20 minus -2 squared. Well, the order of operations says you've got to figure out what -2 squared is first before you can take it away from 20, because subtraction is the lowest priority. Exponents have a much higher priority. So we're going to take 20 minus, what is -2 squared? It's -2 times -2 gives you +4. And in the denominator, 6 minus a -2, let's do KFC and call that 6 plus a +2. So this becomes 16/8, and 16/8 is the same as the number 2. All right, order of operations, simplifying these expressions. The 2 to key on are these 2 problems right there. Okay, everything else pretty straightforward. You're going to use PEMDAS, so you take care of parentheses first, then exponents. Here you've got an exponent, and then multiplication and division are equal partners of each other, and then addition and subtraction are equal partners of each other. So you must do the exponent before multiplying, and you must multiply before subtracting. And once everything is said and done, you would have gotten -13 here, and so on. So I'm not going to work through all of those. I'm just going to focus on B and D. Notice how they have 2 different answers. This has to do with order of operations. Remember when we were talking about early on, I think it was in chapter 2, about how this minus sign means subtraction, but it also means the opposite of, or negative. Well, this is saying the opposite of 2 squared. And how do you find the opposite of a number? You multiply times -1. Since multiplication has a lower priority than exponents, that means we have to do this multiplication after we have taken 2 squared. So 2 squared is 4, and now we're going to take -1 times 4 to give you -4. Here, the parentheses have the priority, which means you've got to take the opposite of 2 first before squaring it. So what otherwise was a lower priority, the multiplication of -1 times 2, is given now the highest priority because you've put it inside parentheses. So now -2 squared is -2 times -2, which gives you a +4 because you're multiplying a negative times a negative. Now, people often wonder why, what's the point? Well, the point is, in real life situations, there are times when we want you to square a number before you subtract it. And there are other times when we would want you to take the opposite of number before squaring it. And so the parentheses here allow you to make those 2 distinctions. Here you would be taking the opposite before squaring it. Here you would be squaring it before subtracting it from another number. There are a lot of adults that don't know the difference between those, but in mathematics, it does make a difference. So here you go. We'll see this periodically come up in just normal problems, and we need to remember the rules for where the parentheses go and how that affects the order of operations there. And then our final problem is a unit rate proportional reasoning type of a problem. Ms. Swanson gives out only one type of candy for Halloween. The local discount store sells 6 pounds of butterscotch candies for $7.50. Use proportional reasoning to solve these problems. All right, so I would generally find the unit rate first. So if it's 6 pounds for $7.50, the price per pound is going to be $7.50 divided by 6. So that is this part right here. Set up your proportion, and then I guess you can see the giant one that's necessary is to divide both $7.50 and the 6 pounds by 1. No, did I just say 1? I meant to say divide by 6, divide by 6. So 750 divided by 6 gives you your unit rate. And now we can think of this as a proportional type of equation. So if the unit rate is $1.25, then make X the number of pounds that you would multiply times $1.25 and make Y the total amount that you would have to spend. And in this case, we don't have to do any division. We don't have to like figure out how many pounds you could get for, or how many pounds you could get for $30. We're not doing that kind of a problem. So you plug in 18 here, and 18 times $1.25 is $22.50. You plug in the 10 here. The amount of butterscotch candies would be 10 times $1.25, which is $12.50. All right, how well did I do? Is it below 10 minutes? No, almost though. All right, head over to our lesson. Take care, bye.
Hey, feeling good, like I should. When in dark, walk around the neighborhood. Feeling blessed.